And then another question, I think many mainframe people who use sysplex and parallel sysplex know the coupling facility. You contributed to a Redbook coupling facility beyond the basics. And my question is, what is a coupling facility data table and what for do you use it?
That's a very good question. Coupling facility data table is a centralized repository. This is used for multiple types of purposes. Its primary purpose is to be similar to that of a vsam file, an in-memory vsam file. The definition in CICS is a typical or standard RDO definition for a file. And in the file, you can specify if it's vsam, native vsam or local vsam, a LSR or local shared resource vsam, or RLS for record level sharing vsam, or SDT, which is a shared data table, which is in-memory for a single address space, or a CF. If the CF type of file is a coupling facility data table. And what it does, it allows you to have a shared repository in memory that all servers in every LPAR across the Plex can use. Okay, so instead of having a file owning region that you would have for a shared file, or instead of vsam RLS, which is a persistent vsam file, you can have an actually in memory. So we have a variety of ways that we use it. We use it as a scratch pad. We use it for passing data back and forth between a parent and child application. Our primary use for it is in our caching solution. We call it Zcache, or out on GitHub it's ZECS for Enterprise Caching Service. And so we use the CFDT as our in-memory type of cache. Some things are better suited for in-memory instead of persistent. Of course, some things are better persistent. So you have to, based upon what your requirements are, you still define it as a file in CICS, but based upon the internal setting, is it a CFDT or local vSAM? Now here's the powerful part about that. So CICS is a app server, a transaction router, a web server, whatever you want it to be. It's a multi-purpose. It supports multiple languages. I believe it's the most robust app server on the market today because it supports all these different languages and features. And it provides these really simple to use APIs. So in our caching service, we could define, for example, Wolfram, you create an instance of your Zcache service. Rich creates his own version of that service. Your requirements need it to be persistent to disk. So when we provision it, we would create yours as a vSAM RLS, and in Rich's, he needs his non-persistent. Therefore, we put his in memory as a CFDT. The program does not change. The Zcache code does the exact same CICS read file, write file, based upon the RDO definition. It either writes it to vSAM RLS or to the CFDT. So here again, you can have one code base with one API, but yet two or multiple different repositories based upon the needs of each individual use of that service.
Okay. Did you have any outages during the last years?
Well, that's a very good question. So we have 2 dedicated parallel sysplexes for our cloud services. And for example, in our Zcache and our ZFAM, our key value database, you can configure each instance to be either active single in a single parallel sysplex, active across 2 parallel sysplexes, or active standby across 2 with asynchronous replication. Our first user of Zcache was an application called Retail Link, and it stores state information in our caching service, and they required active across both parallel sysplexes because their applications lived in 2 different data centers. They average about 15 million hits per day. They've been in production since 2013, so it's 6 years. That's about 32 billion hits that they've processed to our Zcache. 32 billion hits, 0 failures. 0 failures. I don't know if you can find many of their products that can do that. But here's something interesting. I don't remember when it was, Rich. A couple years back, we did take a brief outage on one of the parallel sysplexes. Don't remember what the details were. However, because we did active replication for within our Zcache service, the Retail Link customers didn't experience the outage. because it would go ahead and go to the active system, and then when the other system came back active, we would go ahead and copy and replicate, and then the data would be active on both sides. So here again, even if there was an outage on one of the sysplexes, the way we designed our services to run active-active or active standby, none of the applications actually experienced any issues.
Great. Yeah, really, really impressing, your numbers. And last question, did your company think about alternative platforms for processing your transaction workload?
Yes, a couple things here. First, I want to address a question or something that we hear a lot, and that's about cloud. First of all, I'd like to say that cloud is not a where, it's a how. Cloud does not mean a remote service, remote host. Cloud can be local, it can be remote, it can be X, Y, or Z platform, it doesn't matter. Cloud is a delivery model. It's a how, not a where. And so when you hear about, let's put things in the cloud, there is no the cloud. Cloud is a delivery model, okay? And it's really important for people to understand that. That being the case, we have a lot of applications that look for software that were off-prem of the Z platform, or even off-prem of Walmart because they want it to be cloud-based. So while there have been a lot of challenges running off-prem on Z or running outside of our data center walls, when there have been failures or have been challenges that did not meet our needs, people have come to our team, to me and Rich and to the other two fine technicians on our team, to use the current service we have or even develop new services. For example, there's an application that needed to have a event control process where they send in millions upon millions of events to log and then do searches on those events looking for a needle in a haystack. And they tried some other products off-prem. They tried some in the cloud, wherever the heck that is, and it didn't work. Matter of fact, it failed miserably. And so they approached our team, and we developed a product called ECP Event Control Process that initially, day one went production, is running about 5 million transactions a day. And by this time next year, one of the service types will be running 500 million transactions a day, and another service type we're in the process developing today will be another 500 million. That's 1 billion transactions a day that we'll be running on ZOS. So to answer your question, yes, developers have looked for other solutions off of ZOS. However, when they look for the RAS capabilities that Z provides, the reliability, availability, and scalability, they typically come back to us and look what the Z platform provides. And something too to think about, going back to my little rant on cloud, there's 5 essential characteristics of cloud. There's self-service provisioning, there's metered measured service, there's broad network access, there's pooled shared resources. It's very important to understand that ZOS out of the box has 4 of these 5, the 5th one being the self-service provisioning. IBM's addressing with ZOSMF and some other products as well. So when you look at what ZOS provides out of the box, it's already cloud-like to begin with. And with a little bit of work, a little bit of creative coding, you can create an actual cloud delivery model and a cloud service provider on ZOS.
I'd like to add to that, though, that even though IBM is working on things like Randy mentioned, COSMF and the like, a lot of us have already developed a ton of automation over the years to satisfy our immediate consumers. And, I think that shouldn't be ignored. Randy and I have taken that maybe a step further to make sure we satisfy every need of a consumer. But a lot of shops already do a lot of automation, and it's just a matter of taking that maybe a step further and making sure that your consumers are taken care of immediately, automatically by the things they need. So just wanted to point that out.
Okay. Yeah, Wolfram, if you don't mind, I want to add one more thing to that. You okay with that?
Okay, no problem.
Okay, and Rich talks about automation, and here again, cloud is a how, not a where. And one of the aspects of cloud is the self-service provisioning, which happens to be automation, the automation that Rich was talking about. And so many Z shops already have so many things automated, they're just like really, really close to being able to provide this cloud delivery model with the tools they've already developed. What we did to take this a step further to make sure that we meet the needs of our developers is we made this self-service provisioning a portal. In other words, something from a browser or something that's web accessible. So we developed our own portal called ZPack, which is our provisioning portal. And it happens to run in CICS, and it happens to be COBOL and assembler language. It happens to use just standard stuff that's out of the box that everybody else can use. It uses JSON.
Well, there's a little bit of JavaScript in there, right?
Oh, that's true. There is a little magic in it that we've added.
The front end is JavaScript. The entire back end is COBOL and assembler. Let's make that clear, right? Right.
So now the original version did not have the JavaScript. We did add that to it, though. That is correct. But what we did is we took our automation and we put it in web-based it, through JSON services. And so now our developers can go to our portal. They can see a list of our services. They can select which service they want, click it, they get a drop-down box of all the different things they need to fill in. And by doing so, we do our own API management. We create the URL. We create the security based upon the information they give us. And then in about 10 seconds time, we've provisioned that entire service for them. We give them an endpoint for dev, an endpoint for QA. 10 seconds, they're up and running. That's what it means about automation and giving to the developers what they need and when they need it. The sooner you can give it to them, the more they're going to use this platform instead of going off platform to look for a service. So it's speed to market, but it's also the capabilities that they actually need, something that's useful. So anyway, hopefully that helps.
Yeah, okay. Thank you very much, guys, for sharing this information with us. It was a great discussion, and thank you very much for contributing to our mainframe MOOC in Germany.
Well, thank you for having us. We're honored. It was an honor and a privilege to be there last year at your presentation, to be the keynotes and to have that workshop. And Wolfram, we really appreciate the work that you do to further this platform, not only in Germany, but also in Central Europe and in the United States. So thank you for the work that you do as well.